In this video series, we're going to go through all the coding challenges in on this site, Neetcode.io, and it's 150 coding challenges. We'll start with the group arrays and hashing, and the first coding challenge is contains duplicate. Right? Given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. So if we just write things down, we have an array of numbers, and what we need to do is, let's say that we have seen hash set, right? Let's just write it as a sheet. And once we so we need to visit every number, and we just ask ourselves, okay, 1, is it 1 in scene? It's not. Write it down. Next one, 2, is 2 inside our sheet? It's not. The same with 3. And then once we visit 1, we see that, okay, 1, we already had it, return true. But if we go through all of the numbers and we don't see any duplicates, we just returns false. There are no duplicates. Cool. So let's just write the solution down. We first need to have our scene set like this, and then for num in nums, we just say if num in scene, return true. If not, we add it to our scenes hash set. And if we go through all of the numbers and we didn't find any duplicates, we just return false. There are no duplicates. Let's just run the code. Okay, so yeah, the test pass, and that's the first coding challenge. Next one, valid anagram. Given two strings s and t, return true if t is an anagram of s and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. Right, so we have two variables, and we need to find out if those two variables have the same amount of characters, letters, right? So first what we need to do is count. I will show you how this looks like from collection, import counter. Counter is counter s, and let's just print counter back like so. So you will see what's actually going on. Right? So counter, you see that we pass the string inside, and we have our characters are basically counted, right? So this is the first part of the solution. We just pass this to our counter, and then what we need to do is go through each character for each character in T, counter, and then sorted by 1. Now we did that, but we also need to for key count in counter items like so, and then if count doesn't equal to 0, we know that this is not an anagram. We return false. If we go through all of the characters, we can just return true. So let's run the code. Okay, and test pass. Cool. Okay, to sum. Given an array of integer nums and integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Right. So we got a target 9, and we need to return the indices, right? So we know that 2 plus 7 is 9. So 2 is index 0 and 7 is index 1. And here we have a target 6. We know that 2 plus 4 is 6. And then we have indices 1 and 2, like so. Cool. So first, let's have scene hash map, right? And then if we just iterate num, no, we need index as well. Enumerate nums. We have other num, which needs to be target minus num, like so. And then if other num in scene, we just return scene other num and then current index, like so. If not, C needs to be num and the current index, like this. And then we can ask our interviewer what happens if we don't find any two values. We can maybe return -1, like so. Let's run the code. And the test pass. Cool. Next one, group anagrams. Given an array of strings, group the anagrams together. You can return the answer in any order. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So we get the array of words, strings, and we need to group them by being exactly the same character count, right? So if we have word AET and T's also have the same letters AET, what we can do is we can have a hash map with list or an array, and just basically every time we see a word, we sort the characters and then just append to that list and then return the values. Let's just code it up and print some intermediate results here. So we have results that I found. List. So we have results, which is dict, and then for word in strings, and then we need to do results sorted word. This is our helper function, and then put in work append word, like so, and then we return results.values like this. Let's implement our helper function, sorted word string, and then it returns also a string. Like this, I think. Let's just run the code if this actually works. And it does. We get our intermediate. Let's just print out the results here. So maybe like if it's not 100% clear what's going on, we can just see the output of results, which is basically the default dict, a dictionary. And we can see we sorted our key and value is basically a list, and we just append each word, and by sorting it we know that these words are anagrams, right? If any of these words would have additional or one character and less, it would be a new key value pair, right? Okay, so this is coding challenge group anagrams. Let's move on. Top k frequent elements. Given an integer, an array nums, and an integer k, return k most frequent elements. You may return the answer in any order. So we are given an array, and then k. We see that we have 3 1s and 2 2s, and one's number 3. So we need to return to 1, but this is the most frequent element, and second one, because k is 2, right? It needs to be length 2. Cool. So one way of solving this would be just to have buckets, right? Let's just have a which is basically an array, range, length, nums, and it needs to be +1. Let's just print. So we see what's going on here. So we will have the amount of buckets here, and we will put all the integer by number count, right? So we can, for number count, we can have counter, and then this, and then for so basically it's number and count, like this, and then bucket count append num, and we can print it so that we see what's actually going on here. And you will see that numbers have different counts, right? The indexes represent count here. So basically we know that this is index 1, so 0 there is always empty, but 1, we have 1 3, 2 2s, and 1 3. What we actually need to do now is go from right to left, and then just append this to results. So results is array, and then for I in range counter -1, so less index to the beginning, and then reverse it like this. This, and then results.append num, and then if length of results is equal to k, return results like this. Let's see if the code runs. It doesn't. So what's the problem? Object is not iterable. Okay. Oh, it's bucket. No? That's the problem. Bucket is not defined. Oh. Yeah, I like it's good that you see that I make mistakes, and how to solve it is just to read the logs and yeah, fix the errors. Cool. So this one top k frequent element is also done. Let's go next one. Product of array except self. Product of array except self. Given an integer array nums, return an array answer such that answer I is equal to product of all the elements of nums except nums I. The product of any prefix or suffix of nums is guaranteed to fit to a 30-bit integer. You must write an algorithm that runs in O of n time without using the division operation. Cool. So this would be pretty easy if we could use division operation, but now we basically need to, like our solution is basically when we are at an index 0, it needs to be like the results need to be all the multipliers except this one. So it's 2 times 3 times 4 is 24, and you see the result when we're, let's say, at index 2. Needs to be 1 times 2 times 4, it's 8, and you see 8 as a result. So basically what we need to have is results variable, and we do it like, okay, we need like nums, like so, and then prefix, it's 1 for I in range nums. And then we need to basically results time equal prefix and update prefix with nums I, like so. And then so now we're going from left to right, and we need to also go from right to left. So let's have postfix just 1 for I in range len nums -1 -1 -1 and update post. Let's just print our results here just to see if everything is correct. Okay, it's not correct. It's a bunch of ones. Okay, results needs to be with I. Okay, and yeah, it looks good. So let's just run it with returning results. This should pass all the test cases. Yeah, and it does. So basically what we're doing here is we have prefix, and we're going from left to right and calculating all the multipliers from left to right. And then here we're going from right to left and multiplying all the postfixes, multiplications backwards. And that's why we're able to get the solution. So this is product of array except self. Okay, let's do another one. Valid Sudoku. Determine if 9x9 Sudoku board is valid. Only the fielded cells need to be vetted according to the following rules. Each row must contain the digits 1 through 9 without repetition. Each column must contain the digits, so column is the same, and then we have boxes 3x3, which is basically this, right? These boxes or squares also need to have just numbers between 1 and 9. Note, a Sudoku board partially filled could be valid but not necessarily solvable. Okay, on the fielded cells need to be validated according to the mentioned rules. Okay, cool. So let's just write things down. So what we will be having here is like we have a row. Let's have this row is row 0, right? Okay, and we can have a hash set. So basically having a hash that has 0, and then this corresponds to set. And here in this set, when we visit each cell, we just put it into set. We skip, of course, the empty rows, but we put it like this. It will be like 5, 3, 7 in this case. But if you would saw, let's say 3 again, we will see, okay, it's 3. This is not valid Sudoku board, which is return false, right, from the function. And we do this for both rows and columns. And then, of course, square each square. We also have a set, right? But the difference between column, rows, and this square is that we will have, instead of numbers like here, we would have a tuple which defines which square it is. Is it like here 0, 0 and maps to set, or is it like 1, 1, like so, right? And we will see in code, and we can explain it what's going on here. Yeah. So let's just write the code. So we'll be using default dict. And we will have rows list, and it maps to set. We have columns, and we have squares like this. And what we need to do now is go through each for row in range 9. We need to do the same for column, and then cell is basically board, row, and column. If cell is equal to empty cell, we need to just continue. Don't need to do anything. But now if it's not empty cell, but it's like cell in rows current row, or cell in current column, or cell in squares, basically row divided by 3 and column divided by 3, like so. If this is the case, return false. But if this is not the case, we need to put all the values. So basically rows dot row add cell, calls dot column dot add cell, and then squares column divided by 3. And then if everything goes smoothly through all of the cells, we can just return true. This is a valid Sudoku board. Just run the test cases, and they pass. Great. What can we say about the solution? So basically, we just created default dicts. So dictionaries map to values of hash set. And then for each row, we skip if it's an empty cell. It's not. If it's not empty cell, we need to check if it's actually a number that's not duplicated in both row, cell, and squares. And if this is not the case, we just add the cells to the current row, the current column, and current square. This is basically it. Next one, encode and decode string. So this is locked coding challenge from LeetCode, but we can actually go here and just read the description. Design an algorithm to encode a list of strings to string. The encoded string is then sent over the network and is decoded back to original strings. So I have here, basically we can run this code and see we have an array of words, and we can then encode and decode strings. So we need to implement the functions. So for encoding is pretty straightforward. It's going to be array for word in, and then result.append. So the delimiter to know when the number stops is hash map, and word, like so. If we run this, okay, we need to return like this. So our string is now encoded. So the first part is, okay, number. So basically we have just one digit number, but if we have multiple digit numbers, we know, okay, it's end of the number, and now it's word, and it repeats until the end, right? So now we need to implement a decode string. So for decode string, we need to, let's have a results array, and I is 0, and while I is less than len s, you need to number like this. So j is equal to I, while as j doesn't equal hash pound, which is j plus equal 1. Now we have a number, and is it int, and then we need to have basically, so it's as I and j, like so. And now we need to have a start, which is j plus 1, and end is start plus num, like so. Right, and then result.append as start and end, and then end needs to be, oh no, I needs to be end, like so. Then we can just return results. And then we get back the initial array of words. Cool. So to recap this coding challenge, we can encode the array of words. The delimiter needs to be set just to know what's the number, character count, and with that we can decode back the string to array of words. And that's basically it. Cool. And then the final challenge. Longest consecutive sequence. Given an unsorted array of integer nums, return the length of longest consecutive element sequence. You must write an algorithm that runs in O of n time. So get an array of numbers and longest sequence. So we have a sequence of 100. Longest sequence is 1, 2, 3, and 4. So we return the length of the longest sequence. So 100 is a sequence of 1. 200 is also a sequence of 1, but 1 through 4 is length is 4, right? Okay, so one way of solving this. So the thing is that we need to if we sort the the array, it's pretty easy to find the longest consecutive sequence, but this would be all of n log n time, so it's not. So we need to write an algorithm that runs in linear time. This means that we can use additional space. So with additional space, we can say that nums set is so basically set nums like this, right? And now we can go through each of the numbers, and we need to just check if it's a start of a sequence. And start of sequence 100, we know that 99 it's not present in num set, it's start of sequence, and then we can just move forward. So for num in nums is num start of a sequence. So if num minus 1 in num set, so if nums 1 minus is we can just continue. If not, we know that it's start of the sequence, and then we can just say result is 0, and then while num in set current plus equals 1, so we're just adding 1 and plus equal 1 like so. And then we need to, after that, we need to update results here. And after we're done, we just return results like this. Let's run the code. Okay, the test passed. So to recap, by how to get better runtime, like a lot of times we just can use more space to get better runtime, and that's exactly what we did here. We have num sets, and this is additional of n space, right? And then we just loop over it and check if this current number is start of a sequence. If it is, just count and go forward. If not, just skip it, and that's basically the solution. Okay, so now we're done with first grouping, arrays, and hashing. And yeah, in next videos we'll do 2 pointers and stacks. Thanks for watching, and until next time, bye.